This video is a lecture on Building Java Programs, Chapter 7, Arrays for Introductory Computer Science for Java. So arrays are a really useful tool. You pretty much can't build anything of any real significance without arrays. Certainly none of the major programs that you use today can be done without arrays. But arrays introduce a whole host of new syntax, and they break the rules in so many different ways. So you have to pay close attention this week as we go through arrays. So an array is an index structure that holds multiple values of the same type. So if I want to, for example, have a scanner and collect 5 items, that's no problem. You can just collect them into 5 integers. But if I want to collect 100 of them, or an unlimited number of them, I can't do that. So what I will do is I will use an array and create an indexed structure of however many elements I need. They are indexed by 0, just like strings, and not coincidentally, strings and arrays look a lot alike, because in C, strings and arrays, a string is an array of characters. There is no primitive string class. So, and the only reason it's really different in Java, I think, is because of the multi-byte character set problem, where you can't just pick the third element in an array of characters and be guaranteed that's the third character. So the syntax here, you have to specify the size and the type of the elements. It's easier just to take a look at an example of this. So here we have a declaration, double. And then you have this open, close, square brackets. So this is different. This kind of breaks the rules from what you've seen so far. It's the first time we're putting something here. You've certainly used double before, but you haven't used this here. And notice that there's nothing in here. There's no mention of how many items. It's just a hint to the compiler that when they see this open, close, square brackets, that it is a pointer, really. If you're used to C, that's the equivalent of having a star there. Okay, so it's actually a class, so you have to call new on double, which is the syntax is all different, really, because normally you'd be calling it on like new scanner or something like that, but this is using the type double, and then you've got, instead of normally you'd pass in parentheses and say your argument, here you've got the square brackets again breaking the rules, and then this is telling it how many items to allocate. Another very important difference is that when you allocate, when you declare an array like this sample array, it's different than how you normally declare another variable. So normally when you declare a variable, you get a box like this, we would draw it, and that is the variable. That's where the integer or the character or the byte or the double would go. But that's not the case for an array. For an array, you simply get what is known in C as a pointer. In Java, we call it a reference because Java doesn't really do pointers, but this whole array thing really exposes the concepts of pointers without actually having the pointers. Okay, so what you actually get for sample array is just a box that points to an array of these elements. When it's constructed like this, it will auto-initialize each element to the default value of equivalent of 0. That's not true of all languages. C in particular does not do that for you. So that's something to be aware of. In some languages you will need to initialize. In Java you will not need to initialize it. Okay, so let's take a look at the next slide. Storing values. Okay, so this is similar to strings in Python. If you've used strings in Python, you've already seen that when you have a string, you have an open bracket and you can access a character inside that string. So hopefully you're somewhat familiar with this. But you're going to use square brackets to index into the array, and then you can use it as what we call an L value. So it can be on the left-hand side. You can store it, or you can be an R value, so it could be on the right-hand side and you're getting the value out of it. Values can be stored in a loop. Here we've got a simple loop. So we've got int, open bracket, close bracket. Again, that tells the compiler that what it's about to see is an array. Sample array equals new, again, int. So again, this isn't really a class, it's just the structure of how they do arrays. So we say new, and then type int, and then this allocates 10 items. And these are 0 indexed, so we're going to start with a loop starting at 0, going up to the array length. Now, another example of how arrays break the rules, length is actually a property instead of a method on this item here. And because it's a property, it does not need the open paren, close paren, like it does for string length. So, breaking the rules. And then we're going to increment through this, and so we're going to look at each item of the sample array, and we're assigning into the value of the sample array with a random number between 0 and 99. We convert it to an integer. If we didn't convert it to an integer here, it would throw an error. Okay, so that stores it. Then we do the same structure in order to loop through the array, and then we're printing out open bracket, sample array item, close bracket. And again, here we're pulling the value out of sample array using the exact same syntax as we used to put it in. And it's interesting to note later on in this lecture, we will talk about how we can make a shorthand for this very common access, as well as get a shorthand so we don't actually have to do this. This entire thing here can be avoided too. Array traversal. So it's very, very common. You're going to traverse the array just like this. You're going to go from 0 to the array length, and here's the sample here. So we're going from 0 to the list length. There's actually 5 elements in this list. So each item is going to be equal to 2 times the item plus 1. So we go 1, 3, 5, 7, 9. It's just giving us the odds, and then it's printing out this list. So as you're indexing into an array, you can definitely get an out of bounds error. So Java is going to throw an exception, and all the normal exception handling rules apply. You can catch it if you want, otherwise it'll interrupt the program. So indexing starts at 0 here, and let's see, what's the error? So the astute observer will notice that there's actually a bug in this slide. This should actually say less than or equal to length, because the way it's written here, it actually will step through 0, 1, 2, 3, and 4. What this is supposed to be illustrating is that at length 5, it's going to throw this exception. So this actually should be less than or equal to in order to hit that exception. Okay, let's take a look at the next slide. So random access is another way that the arrays break the rules. So far we've been using sequential access. So for example, in the scanner, we would go through from one item to the next, doing it sequentially. Now we have random access, so we can access any item that we want. And it can do it very quickly and efficiently because the array is allocated as one big block of memory. And using expressions very similar to the loop expressions that we've used in the past, for example, to print some ASCII art, you can access the item directly by calculating how far into this array the item is. And that's true whether it's one-dimensional, two-dimensional, n-dimensional. We won't get into that. But another thing that we haven't talked much about in this class so far is speed. So programmers are judged by how fast they can write the code and by how fast their code runs. So using arrays is always a good idea if possible. So that's an advantage of arrays to give us random access. And that's also to think about. When you have a program where you need to be able to access items that you've stored in a random manner, you need to think about using arrays in order to be able to get to do that. So, and yet another way that arrays break the rules is that arrays can allow you to change the contents even when you pass them into another method. So it's always been the case that, for example, strings are immutable. You can pass strings all you want, and you can never change the string once it comes back from a routine. It's a different string. That is not the case with arrays. And so this is, again, another case that's breaking the rules. So here we have a sample we've got a main, we've got this list of 5 things that are the odd numbers we just looked at. So we're going to print this out, and then we're going to call increment all, which is down here on that list, and then we're going to print them out again. And increment all goes through the list using the same format we've seen before, and it does a ++ on each item. And notice again that this is what we call an L value. You can assign it, you can increment it, you can do whatever you want to it. So this actually modifies the array. When it comes back from increment all, list now actually is different. We're printing it out. It's a little bit challenging to explain exactly why, but if we think again about how does declaring this list variable happen. List is just a pointer. It's not actually the array itself. I've stepped back a few slides to take a look again here. So imagine this is list. List is just this box here, but this box contains a pointer to my list of items. So I'm using this in main, and then I pass down this box in a method call. Okay, this box is passed to the next routine, and it is still a pointer to the same items here. Okay, it copies this. In the new routine, there's going to be another box, but it copies the pointer in the new routine, and it's still pointing to this back here. We have another slide later on that'll show you that you can have multiple arrays pointing to the same physical array. Okay, so when I change items in list now, even though it's being called down here and we're changing it up here, when I return back to the original procedure, it's pointing now to modified elements. Okay. So remember, we can change the contents of arrays in submethods. So methods can return arrays, and this is another way that it breaks the rules, because normally when we've had a function down here and we have a local variable in that function, we can do anything we want to that local function, but when we return, anything that we've created in this local function generally goes away. We've been able to return an int, a value, okay, or a string value, but this is well, I guess it's about the same. It's the same as for a string, because you've been able to create a string in the past and then return a string. So here we're declaring this new. Oh, here's something new though. So here, when we're declaring the array, we are not passing in a fixed number. We're actually passing in a parameter here. So you put a parameter there, and then it's going to create the array and it's going to return it. Okay. This is strictly shorthand, and you don't have to learn this. But remember earlier when I was showing you the real common loop structure? Let me go back and point that out. So here's this real common loop structure where we go from 0 to the item's length incrementing. Here we've got it again, and here we've got it again, and here we've got it again. Well, it happens so frequently that they decided to give it a shortcut. And this is unique to Java. It doesn't happen in C. But so you can say for, and then whereas normally you would say int each equals 0, each less than or equal to new array dot length, each ++, you just shorten it to say for int each, or whatever you're going to use here as your loop variable, colon, and then the name of the array you're going to loop over, new array. So this is just shorthand for writing out a for loop. It's not, you don't have to use it, but you should understand what it is in case you see it. And again, this is only for arrays. And so once again, they're breaking the rules. Why only for arrays do they have this shorthand? Why don't they have it for anything else? Can't say, but it's breaking the rules, and that's what it is. So they call this the for each loop. Initializing arrays. So unlike all the other data structures, you can actually fully initialize the array here. In C, no matter what your data structure is, you can initialize it like this, but they only give it to you for arrays here. So again, the int open close paren saying that this is going to be a pointer to an array, month, days, and then you have, now we have squiggly brackets, and then we have all these data items. So this is breaking the rules, and there needs to be a semicolon here. Yeah, you see the semicolon right there too. So it's going to store, you can initialize all of these items. And you know how we were talking about string literals and other literals? Well, this is an array literal. All right, so now we're going to talk about some higher level functions of the arrays class. So there's a built-in arrays class that gives you some functionality. Remember that arrays are allocated as a contiguous block of memory. So in our very first demo, when we allocated 3 items, that's all you're ever going to get. If you want to make it 4 or 5 items, you can't do anything. You've got to create a new array. But they did provide this function in the arrays class called copyOf that will help you by you pass in the length that you want it to be. So in this case, we're going to pass in twice of the array data's length and the source array data, and it's going to return a new array, new data, that is going to be copied over. So here's a list of those functions. So you can copy of, and this returns a new array with the given size. The old array is going to be discarded, basically. Then copy of range, so you can take just a part of it. This, we need an equals function to test if the 2 arrays contain the same elements. We can fill every element of the array to a given value. You can sort the array, which is really nice. And you can convert the array to a string. And this is one I wanted to mention. I mentioned earlier that in one of those first slides, we had to do some code to print out something like this, open bracket 357. So instead, what you can do is you can use the arrays.toString of the array, and it'll do it for you for any of the built-in classes. Now we're going to talk about some common array algorithms, things that you'll frequently want to do. So for example, here is how do you count the number of times a value occurs in an array. So here we're using the shortcut terminology. This would normally be for int n equals 0, n is less than list.length, n++. Then if n is equal to the target value being 5, then we increment the count. Now earlier I omitted to say that not only is it shorthand for this loop here, but this reference here is different too. So normally n is just going to be the index. So it kind of looks like that we're just checking against the index, but this special for each terminology or syntax actually pulls the new value of list into this integer. So that's another part of the shortcut. So we're checking if the value of list open paren n close paren is equal to target, and if so, we're incrementing count. Here is how to find a value and return its location. So they're going to go through this array. If the item is equal to the target, then we turn not the item, but return the index I, or we return -1. And I think this could have been written using this same terminology here too. Oh no, it couldn't, because we were returning I. So if we use this syntax here, oops, then I would have actually held the value. And so we need to actually use the long form here in order to get the index. Okay, how to reverse array. So you can, first we're just going to take a look at how you reverse 2 items here. If you have an x and a y, and you say x is equal to y, at that point, both values are going to be the same. Because then when you try to get x, it's no longer the old x, it's actually y. This is not going to swap anything. What you have to do is you have to take, so if x and y are that same thing, you have to first take the value of y and put it somewhere temporarily. Then you can overwrite y with x and put the temporary into x. And now you can actually swap. So we started out as x being 3, now x is 78. So that's just in general how you swap something. So we're going to need to use that in an array now. So we're going to walk down this array that we're passing in list. So we're going to walk through it only half the length. And that's because we're going to swap the first item. I'm just going to try to, oh, here we go. Yeah, we're going to swap the first item, the last item. the second item, and the second to last item. And then you don't actually need to swap this one. So if there are 5 elements here, 5 integer divided by 2 is only going to be 2. We only have to do the first 2 items. This one remains the same. So we've got our subroutine here, swap, that does that swapping we just talked about. And notice that we're passing in the list and the I and the J. So if we had just passed in list open bracket I close bracket and list open bracket J close bracket, passed in those 2 items, swapping this wouldn't do any good. It wouldn't actually affect the list. It's only because we're passing in the list, and again that's a pointer. Then when we do list open I, well, I got to figure out a faster way to say this, the ith element of list and the jth element of list, then it's actually looking at those particular memory locations and not just the values of them. So we're able to swap these items here, and then when we print it out, it goes from 1 to 5 to, again, to now 5 to 1. Okay, so there's 2 separate things here going on. One, well actually 3 kind of. One is the swapping technique that I showed you in the previous slide. Second is that when you're trying to swap something, you actually have to pass in the array, not just the ith and jth element, because that isn't going to swap anything. It's just going to swap the values. What you need to do is actually pass in the array and then the indexes. Then you can operate on it. And then the overall algorithm of traversing it from 0 through halfway down the list and then swapping the items. Oh, and I should just point out, so here, so this item is equal to the length minus 1, okay, and then we have to subtract I. So it's the length 5 minus 1, 4, so we want item 0, 1, 2, 3, 4, okay, then minus I. So it starts out as 0, and then we get this one, and it's walking its way back the list. This is a kind of a common thing that you'll see, so get used to seeing that. It doesn't matter whether you write minus 1 minus I or minus I minus 1, doesn't matter. Okay, string traversal algorithms. So again, strings were originally just arrays of characters in C. And so you treat it the same way. We've probably seen this before when you're dealing with strings. So here we're going down the length of a string. We're taking care at I. So again, strings, arrays break the rule because here in strings you cannot just do an open bracket I close bracket. You can't do that here. You have to use care at, and that's because of the multi-byte character set problem. If you try to look at the third character, that may not be the third actual Unicode character. Unicode characters can be two 16-bit numbers stuck together. Okay, and here's a way to reverse the string. You're going to go through the length and you're going to build it backwards. You're going to put the text at and then stick on, and you're going to stick every character at the front of the string, and then that'll reverse it. Okay, so we talked a little bit about reference semantics, and here we're going to talk a little more detail. So this isn't really any different than what I've talked about. It's just re-emphasizing it. So when you have an integer, it stores the value in that variable, but in an array, it stores a pointer to your array. So the integers and characters and doubles, all those other types use what we call value semantics. So it passes the value in when you pass a parameter, and changing that value doesn't do anything to the place where you called it. But reference semantics, we're passing in a pointer to that array, and therefore you can actually modify that array. It's done for efficiency so that you don't have 1,000 items being copied back and forth between procedure calls, and it's so that you can share things. It would be nice if you could share strings too, but that's not a luxury we have in Java. Here we're talking about, this is a more detailed example. So here we've got 2 lists here. They're going to set the lists up the same way. So here it's showing you they're the same. And then we're going to be doing an assignment here. So list 3 is equal to list 2. Question is, what is list 3 going to be? So list 3, this is just like what I was saying when you pass something, an array, as a parameter, okay? This is the equivalent of the parameter inside the array. It's a new variable, but the variable points to the same array, so that when you're, in this case, modifying inside this one procedure, you're modifying list 3, it actually modifies list 2. And similarly, when you pass a procedure call, that procedure, that subprocedure, is going to be modifying the original array. So here it's shown that both list 3 and list 2 are modified with each other. And just like with strings, a simple equal equals will not necessarily work. So back here, this list 2 and list 3 are equal equal, okay? But list 1, if we go back here, list 1 and list 2 are not equal equal. Okay, you're going to have to use the array equals function to see whether they're the same or not. And I believe, let's see, where does it refer to that? Yeah, we need to go to the next slide. Here it talks about array.equals. That will actually do it just like for the strings. You need to use the EQUALS method, not the double equal sign. Java null. Null is no object, so just like we have strings that can be null, which is the same as doing quote quote. Okay, this integer list is null. Now, I don't think you can do quote quote for that though. You're going to have to use null, or I believe you can use an open bracket, close bracket as well to be the equivalent. I'm not 100% sure, but I believe so. I don't think this should be too surprising that when you allocate an array of objects instead of the primitive types, that it will create an array of objects, but those objects have not yet been created. Just like if you have an array of doubles, it's created with the equivalent of a null, so doubles get 0, these objects get null. Okay, you still have to put an object into each one. So here we create an array of 3 points, where point is a class. Okay, this is not a predefined Java class. This is presuming that you have a point that has an x and a y. We've used this kind of thing in previous chapters. So this creates 3 points here, and then points 0, 1, and 2 have to be assigned. In this case, we're assigning them with a new point of these values. So you've got to do that, otherwise you'll just have null. And then finally, we've got multidimensional arrays. You can have an array, so this is assuming you have just a static double variable, okay? When you define a double open close bracket, that's a one-dimensional array. If you have 2 sets of brackets, that's 2-dimensional. 3 sets of brackets, 3-dimensional. What does that really mean? It just means that when you access the items, you can use this format where you have you're accessing basically a row and a column. Okay, you can actually mathematically have the equivalent by just using a single array. But let's say that it was allocated as 3 rows by 5 columns. You can do the mathematical equivalent. You can achieve the same functionality by creating a single array of 15 items. And you can calculate the virtual row by taking 5 times the row, so that row 0 starts at 0, row 1 starts at 5, row 2 starts at 10. But this is simpler. This does the math for you. And to have a third dimension, then it gets more complicated. You can think of it as a row, a column, and a z-axis or something. Or in ASCII art, we've done like a row, a column, and then a separator. But anyways, you can have multi-dimensional arrays, okay, and all the same things apply. It gets a little bit more complicated, obviously, with more dimensions, but it can be done. Okay, so what have we talked today? We've talked about arrays and how arrays break all of the rules pretty much. So an array is a continuous block of objects. They all have to be the same object, whether it be a string, an integer, a point, some class. It's all put under one name. There's an array index, which ranges from 0 to the length of the array. and you can traverse them using for loops, or you can do the special for each loop. You can compare them using equals. You can you can use equals, but it's just like a string where it's not going to give you what you want. Arrays have fixed size, and you can't directly println them, although you can use the arrays class, the arrays class .toString. You can put that into a println. You can have arrays of objects. We also talked about initializing arrays, and arrays are automatically initialized to 0 or the equivalent of 0. So for an object that's null, for a double it's 0.0, etc. And you can have multi-dimensional arrays. So again, arrays are really, really useful. They're something you're definitely going to want to use. Unfortunately, they break all the rules, so you need to learn the syntax kind of all over for many cases. Things like length, whereas length, you've always used length open paren, close paren on a string. Now you got to do dot length for an array. So that's kind of annoying, but it's a very, very useful feature. And again, the reason why you want to use an array is because you want to store a lot of stuff. You don't know how many things you want to store, because you want to be able to access those items randomly rather than sequentially, because you want to store them efficiently, either in space and or execution time. These are all great reasons why you're going to love using arrays, but it does take a little bit of relearning to use them. All right, good luck to you.